Hey guys, my name's Scout. This is going to be a tutorial on how to design a wing with an aspect ratio of 10 and taper ratio of 0.6 in XFLR5. So let's go ahead and open that up. We're going to go over to module. We need to enter the 2D analysis first, so just go to XFLR direct analysis. Let me go over here to design, go to naca foils. We're going to be doing the 2415 naca airfoil. I'm going to put about 200 panels on that. And then just hit OK. And so we need to gather data for the 2D airfoil before we can actually run the analysis on the 3D wing. So we're going to go over here to analysis, do a batch analysis, and we're going to iterate it through a bunch of different Reynolds numbers. So you can see we go from about 100,000 to 1 point, like 12 million. And this is just to make sure that we have enough data for that 3D wing analysis to interpolate from. And we're going to be iterating from -15 to 15 degrees angle of attack with increments of 1 degree. Let's go ahead and click Analyze. You can see we have these generating over here. Okay, now that that analysis is completed, we can close it and head over to our wing and plane design module. We go over here to plane to find a new plane. We'll just name this TR for taper ratio of 0.6. And then we're just gonna, uncheck these boxes because we're only focused on the wing for this analysis. Let's go over to the main wing, hit this define, and then I'm gonna set our chord length to 1, offset to 0, and then make our foils like that. And then, so for this one, we're gonna be actually using a taper ratio of 0.6. So we have to set the second chord length to 0.6. You can see that's kind of the shape we're going for. We're also we want this to be at an aspect ratio of 5. And in order to do that, we're gonna have to set this or an aspect ratio of 10, I apologize. But we're not gonna set it to 5, because as you can see, whenever it's set to 5, because of the taper, it's gonna be set to 12.5 aspect ratio. So we're gonna lower it. I think 4 was giving me, yeah, so 4 actually works. You could do the equation for a trapezoid, but really just going through it, we see that 4 works. So let's go ahead and save. Hit save again. And then now we can run our analysis on this tapered wing. I'm gonna hit define analysis. We're gonna make it 50 meters per second. Make sure it's on type 1 polar. An analysis, we have LOT, and then everything else looks right. I'm gonna hit save. And then on this side, we see that we have from -5 to 15 degrees with increments of 1. We're just going to run that sequence. And our data looks generated. So, yeah, over here we have, the CLCD graph. We can also make this CL alpha. So, you have that kind of going. And we can also, so we see we have this alpha versus efficiency. The Oswald's efficiency number. CD versus alpha. Alpha versus CL over CD. And with all these graphs, if you wanted to export them to Excel per se, you're just gonna right click on them, go to current graph, export graph, and then choose your folder, your file destination, and then it'll be imported as a CSV, which you can easily upload into Excel. And then, so we have these plots. If you wanted variation across the span, you're gonna go to your op point view. You're going to be able to, let's say, so this is on lift coefficient. So lift local lift coefficient variation along the span of the wing. You can also do induced angle of attack, total angle, also important, and then induced drag coefficient. And to plot any of these, again, you just want to go ahead and right click on the graph, go to current graph, and then export. And the same thing, it's going to export as a CSV file. So very easy to access within Excel. That about wraps up this tutorial. But you have a good day. Bye-bye.